So in this video we will just see how to evaluate integral 0 to pi by 2 sin x power n dx cos x power n dx, that is integral 0 to pi by 2 cos x power n dx when n is even and when n is odd in both the cases. So it is very simple and easily 2 marks can be scored with this. So it comes under reduction formula. So what you do is just first see that you don't have product of two sine as well as cosine. You have just sin x power 10, and in this case only sin x power 7, and here cos x power 12, cos x power 9. You can see that in one case it is even, the other case odd, even, odd, sine, cosine, sine, cosine. So first have that what is given to us, and then you start doing like this. First write whatever you have in the index. So here it is 10. Then keep on reducing it in a zigzag way. 10, so 9, then 8, 7, 6, 5, 4, 3, 2, 1. So when half comes, have it in your mind that the next one should be pi by 2. So you know actually how this is derived, but this is all those derivations need not be remembered when you do section equation. So just simply write it in a zigzag way, and remember that when half comes, the next one should be pi by 2. And then when you have odd number, you will be landing at 2 by 3. So once 2 by 3 comes, put it the next one as 1. So just see this. You have 7, 6, 5, 4, 3, 2. So 2 by 3 comes, so the next one should be 1. Crudely you can remember, but you must know how it is derived. So that case is different, that we have already dealt. But here how easily that we can do. Whatever you have in the index, put it in the denominator, and then keep on reducing 7, 6, like our countdown. 7, 6, 5, 4, 3, 2. Once 2 by 3 comes, the next one should be 1. And here 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Once half comes, the next one should be pi by 2. In the same way for cosine also. You have 12. So 12, count down. 12, 11. But remember the index, whatever you have, it should be first put in the denominator. So that is alone to be remembered. And then you count down. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, half comes. So whenever half comes, it should be pi by 2. Half means you have to have the next one to be pi by 2. Half means pi by 2. So the next one, whatever you have in the index, put it in the denominator. Then keep on reducing. 9, 8, 7, 6, 5, 4, 3, 2. 2 by 3 comes, so the next one should be 1. So 2 by 3 means 1, and a half means pi by 2. So in that way you can easily score 2 marks when these questions are asked in section A. And then if we have the combination, that is we have both sine and cosine coming. See, suppose I have say sin x power 4 and cos x power 5, say. Then in that case, how are we going to proceed? See here the possibilities are this is even, this is odd, or both of them are odd. This one is odd and this one is even, and both of them are even. So 4 cases that we can have, but whatever may be the case, we need not bother. Again, the same procedure that we are going to follow. What we are going to do in this case is you have to add these two up and put it in the denominator. And then of the two indices, anything can be reduced, but the lesser one usually we choose. So between 4 and 5 we have this to be the number which is less than the other one. So we start reducing that. So whatever you have, 4 minus 1. So that we have to write. So that in this case we have as 3. Now we can reduce this 3 minus 2, so you have 1, and 9 minus 2, so you have 7. Then you cannot further reduce it, so what you do is you put I. Now of the two, whichever you have reduced, for that correspondingly you will have to write the suffix. So here you have reduced the power of sine, and that happens to be even. Even means ultimate integral you have to have it as 0. So I0 5. And then this has to be evaluated, for which we will have to make use of this. So you have 9, 3, so 1 by 7, here 5, 4, 3, 2, 2 by 3 comes, so you have 1. And then suppose I have 0 to pi by 2, I have this to be say 5 and this to be say 4. Again we'll have to add these two up and put it in the denominator. Of the two, this one is lesser than this, so we reduce it by 1. So 4 minus 1, you have 3. Then 3 minus 2, so that gives me 1. 9 minus 2, that gives me 7. I 5 0. So here if you have this to be even, whichever you are reducing, if that happens to be an even number, then your ultimate integral you will have it as 0 here. The other one will be retained as such. So now again 9, 3, so 1 by 7, and then here 5, 4, 3, 2. So 2 by 3 comes, so the next one should be 1. So what we have had here in this case is power of sine. Suppose generally if we denote it as a sin x power m cos x power n dx. So cases, in this case m even, n odd, and in this case m odd, n even. So both of them are different. That case is over. Now suppose we have both of them to be even, say what will happen, and if both of them are odd, what will happen, that we will see. So suppose we have the next one. Suppose we have both of them to be say even, between 0 and pi by 2 that we have. Usual procedure, we'll have to add these two and put it in the denominator. You can reduce either the power of sine or power of cosine, that doesn't matter. Usually we choose the lesser one. So 6 minus 1, that gives me 5. Then reduce this by 2, so 3. 14 minus 2, so 12. 3 minus 2, that gives me 1, and 12 minus 2, that gives me 10. Now further you cannot reduce this, so next your I should come. And this one is even. Okay, so when you reduce it, if it comes out to be an even number, then you'll have to write like this. So you have I8 0. So you will have this to be say 14, 5, okay, 3 by 12, 1 by 10, and then this one 8, 7, 6, 5, 4, 3, 2, 1. So once half comes pi by 2. Okay, and then 8, 1, both of them are odd, say. I have this to be say sin x power 5 cos x power 7 dx. So in that case, what happens? You will have to add and put the sum in the denominator. You can reduce the power of sine or cosine, that doesn't matter, but lesser one we'll take. So 5 minus 1, you have 4. Then subtract 2 from that, so 2 by 10. Further you cannot reduce this by 2, so we stop at that. So your I should come, and you have reduced the power of sine, which is an odd number. So ultimate integral in that case, odd means it will land up with 1. So I17. Then have we to further calculate this? There is no need. We will have to have of the two indices, if one happens to be 1, then you'll have to just add and put it as such in the denominator, 1 by 8. Of course further this has to be simplified in all the cases, but Up to this much, if you know, then the other simplification part, all of you know how to do it. So you have this one. Now, even in the previous case, see, in the previous case, we had like this 5 1, but remember the other one we had, we reduced this power, and that happened to be even number. That happened to be an even number. See, in this case, suppose we will have the power of cosine. We will have the 0 to pi by 2. We will have sin x power 4, or sin x power 8 we shall have, and then cos x power 5 we have, say. Let us see what happens. So in this case, again, you will have to add and put it in the denominator. This power is lesser than this, so you have 4. Keep reducing. 4 minus 2, 2, and then 13 minus 2, 11, and then further you cannot reduce this, so I should come, and you have reduced the power of cosine. This one should be retained as such, and this happens to be an odd number, so you'll have to put it just 1. And whether it has to be simplified further, there is no need. You'll have to write 4 upon 13, 2 upon 11, 1 by, just add and put it in the denominator, so 1 by 9. So when you keep reducing, whichever one of the two powers that you can reduce, answer is going to be the same, but usually the lesser one only we reduce. So in this case, you see that this is an odd number. Whenever you have odd number, ultimate integral, you will have it as 1. And whenever you have even number, you will have the ultimate integral to be 0. The one which you have not reduced, retain as such. You should not do anything with that. Okay, so you have this, so you can choose on your own any number, and you can proceed with that. See, suppose I want to have at random whatever comes to your hand. So suppose I have, say, this to be 6, and the other one to be, say, 5 or 3 cos x power 3 dx between the limit 0 and pi by 2. Then add them, so you'll have 9, and then reduce the power of lesser one, so you have 3 minus 1, that is 2. You cannot further reduce it. Put I suffix, the one which you have not reduced, write as such, and then this one being odd, you'll have to put 1. So you have 2 by 9, 1 by 7. 1 by 7. All these have to be further simplified. So that is not discussed here. Given any such combination, how you can easily approach. So only that is explained. So 2 half means the last one should be pi by 2. Half means pi by 2. 2 by 3 means 1. 2 by 3 means 1. It has to end with that. And in this case, you're reducing the power of a sign. So that happens to be even. So ultimate will be 0. So when you have 0, then this procedure is to be followed. 5, 4, 3, 2. 2 by 3 comes, so 1. So 2 by 3, when it comes as 2 by 3, the next one should be 1. When it comes as half, it should be pi by 2. So that is as far these two are concerned. Once that is remembered, when you apply that over here, then there will not be any problem. And in this case, what is to be remembered? When you have the product of the two, one which is less than the other one can be reduced. So suppose you have both of them to be the same, you can choose. See, suppose I have, say, the power of both of them to be the same. Suppose I have sin x power 5 cos x power 5 dx between the limit 0 and pi by 2. If only the limits are given, this can be applied. You add them and then put it in the denominator. You can reduce either the power of sine or cosine. So 5 minus 1, 4. I am reducing this. So this, and then keep reducing by 2. So 2 by 8. Then I, this one you have reduced, that happens to be odd. Odd means you have to land up with 1. Even means ultimate integral. You'll have to land up with 0. So you have this is odd. So 1, the one which you have not reduced, don't do anything, just keep it as such. So 10, 4 by 10, and then 2 by 8, 1 by 6. Further you can simplify this. That part it is not discussed here. And then suppose I have, say, sine x power 8 cos x power 8. Both of them are the same between the limits 0 and pi by 2. So in this case, add them, put it in the denominator, and then you can either reduce the power of this or reduce the power of this. Suppose I reduce the power of this, say 8 minus 1, 7. And then you have that to be, you have to keep reducing by 2, so 5, and here 14, 5 minus 2, 3, 14 minus 2, 12, 3 minus 2, 1, and 12 minus 2, 10. Further you cannot reduce, so I should come. And here you have not touched this, so put it as such. And this you have reduced, that happens to be even. Even means 0. So you'll have to have I80. Then you retain this as such. Finally you can simplify this further. So you have this one to be 8, 7, 6, 5, 4, 3, 2. Half comes, so you have pi by 2. So if half comes, pi by 2. If 2 by 3 comes, 1. This is from the first set. What we learned, just sine alone or just cosine alone. So in that case, whatever we had, so from that this one follows. But as for this is concerned, when you have even means ultimate will be 0, odd means ultimate will be 1. So you can try a lot of problems. You can give on your own the indices, and you can practice on your own.